Washington State University. Go Cougs!
Hello everyone. In this video, we're going to cover lesson 4 of the Working with Activity and Health Data module. Specifically today, we're going to talk about visualizing data. Visualizing data is very important for data analysts because it's a very quick way to perform exploratory data analysis. Initially, when working with a new data set, you may want to create a plot to get a high-level overview of what the data looks like. And then as you start to drill into maybe different columns of the data frame, different characteristics of the data, or different groups of the data, you'll start constructing more specialized plots as needed. Plots are really great for visualizing data because our human vision system allows us to pick up on missing data or trends or outliers or patterns really quickly. So this will save us time versus trying to analyze data numerically or looking at it initially in a program like Excel or even just a text file. So in this class, we're going to use the Matplotlib package for plotting. There are several different Python packages we could use, but I chose Matplotlib for several reasons, including it's easy to use, it's highly documented online. So if you ever have a question about how can I do this in Matplotlib, Googling it will usually lead you to a result. And it also has support for inline plotting in Jupyter Notebook, which we'll see shortly. And lastly, one thing that I'd like to add is it is included in the Anaconda 3 Python distribution, which means you already have it installed on your machine. So let's talk more about how to use Matplotlib. There are 3 different ways to use Matplotlib. The first one is the most common for exploratory data analysis and data scientists to use, and it's a non-object oriented state machine environment. You can think about it more as an interface to several quick and dirty plotting commands. Let's skip number 2 and look at number 3. Number 3 is a purely object-oriented interface. So this would be for if you're going to write a desktop application with a graphical user interface and you want to have some plots in your GUI. Then you'd want to use the OOP interface so you can manage those references to the objects. Number 2 is a hybrid between purely state machine and purely object-oriented. We'll use 1 and 2 in this class. Initially, we'll usually start with 1, and then as we need to add some bells and whistles to our plots, then we'll start to work with 2, where we need to get some references to some of the artists used in Matplotlib. So let's take a look at an example. We're going to generate a simple plot in Jupyter Notebook, and I'm going to show you how nice it is that the plots can be rendered inline. By inline, I mean the plot is going to appear in our notebook immediately below this code cell. Whereas if you were running Matplotlib, say in Spider, then these plots would be popping up in new windows. So first we're going to set the magic command Matplotlib to be inline, meaning we want these plots to show up inline instead of in new windows. And then we're going to import matplotlib.pyplot as plot. So this is going to be our state machine interface, and PLT is usually what the state machine interface is called. And import numpy as NP. So let's generate some X and Y data to plot. Let's do a curve for the first 100 squares. So I'm going to assign to X np.arange 100, and I'm going to use vectorization in order to square every element in X. And now I have my data and I'm ready to plot X and Y. So I'll use the matplotlib pyplot command plot, which will choose the appropriate curve for this data, which will be a line curve. And I'm done making changes to this plot, so let's go ahead and show it. So here's our plot, which nicely shows up in line in our Jupyter Notebook. Nothing too fancy right now, but this is already looking really nice as part of describing our data and our context in Jupyter Notebook. The one thing I'm going to touch on before we just start diving into some Matplotlib examples is if we do need to access the references for the objects associated with Matplotlib, it's good to know what those objects represent. So here we have a figure, as you can see in this example. A figure is composed of axes, and an axis is composed of multiple axes objects, axes such as an x-axis or a y-axis. And then we have a curve on this axis, and this curve could be represented by a lines 2D object, for example. More of a description of each one of these objects are here. I've included from the Matplotlib website. If we do need to work with the objects in Matplotlib, it'll typically be in one of two ways we'll get them. We'll work with the figure, the current figure, and the current axis. So plot.gcf will get the current figure, and plot.gca will get the current axes. If when we construct a new plot, we want to immediately get the figure and the axes instead of after plotting, we can do so with the subplots command, which will create and return a new figure and axes object. So we'll learn more about using the object-oriented interface as we go. For now, let's go ahead and shift gears and look at some examples of different types of plot in Matplotlib. So what I've done for the remainder of this lesson is borrow some code from the Matplotlib website and adjust it in order to show an example of different kinds of plots. So let's go ahead and run through these. So first, we're going to look at a line plot again, but this time I've added an X label, a Y label, and a title. So X label, Y label, and title. The Y label is X squared, which I have used the math mode of LaTeX in order to have a nicely typeset X squared. So keep that in mind that we can use LaTeX for nicely typeset labels and text on our Matplotlib figures. There are quite a few other things we can add to our Matplotlib plots. For example, in this code here, I've added multiple curves. So I have 3 plot commands, and each curve has a different line style associated with it: blue dash, red long dash, or green dot, green scatter. And I've added a legend with a call to legend, specifying the location to be the upper left corner. So here's an example of multiple curves on the same plot with a legend to identify the curves. Next, let's take a look at bar plots. Run this code. So we can create a bar plot with a call to bar. And here we have 2 calls to bar because we have 2 different sets of rectangles, one for men and one for women. So we see we have blue represents men and red represents women for these particular scores. We're not very interested in what the scores are, but just an example of creating a plot, a bar plot specifically. So next, let's take a look at histograms. So here in this code, we're generating some randomly sampled normal data. So the normal distribution is parameterized by mu and sigma of 100 plus or minus 15. And here's our random data. We'll go ahead and use the hist function in order to create a histogram of the data. So here's our data, and 50 is the number of rectangles. Norm set to 1, we'll normalize the data, and we'll set this to be green with an alpha of 0.75. So the alpha just means to make this somewhat transparent. So let's go ahead and run this. So here's the histogram. There are 2 other things I'd like to show you about this plot. The first is the use of a text label here. So with the command text at coordinate 60, 0.025, which is right here. and it's using LaTeX to show mu and sigma for this normal data. The other thing to point out is the grid lines. So plot.grid true gives grid lines on the plot. The next one to take a look at is a scatter plot. So using the function scatter with x and y coordinates, we can plot points. We can also encode additional information about the data on each point. So for example, the diameter of each point could be significant of or representative of some value, and the color of each point could also be indicative of some data field. So here we're just working with random data, but you could see how we could actually plot n-dimensional data with a scatter plot because there's so many different characteristics of the plot that we can customize. Moving on to box plots. If you haven't worked with box plots before, don't worry too much. I'll give you a brief crash course now. So a box plot is a non-parametric approach to visualizing a distribution. So this orange bar here represents the median of the data set. The box surrounding the median represents the interquartile range, which is the 75th percentile to the 25th percentile. And then the whiskers out here typically represent some constant times the interquartile range, such as 1.5 times the interquartile range plus Q3 or subtracted from Q1. And then these circles out here, these represent outliers of the data. So it's a really great way to immediately see the distribution of your data without assuming that, say, it's normal, for example. And here are a bunch of commands that create all of this random data, and then boxplot is the figure, the plotting function that will create these box plots. Moving on to our last one for this lesson, heat maps. So let's run this code so we can see the heat map. So a heat map is going to display n-dimensional data, particularly in this case, three-dimensional, where we have x and a y value, and at each x and y value, we have value encoded as a color. So here's our color bar here. So for values that are greater than 1 or close to 1, close to -1, we have red and blue, and then in the middle, 0 is white. So here's a bunch of random noise, and you can see that it seems to be fairly balanced between a mixture of red, white, and blue. So the command to create this heat map is color bar, and in this example, I will point out that we are using the objects for a figure and an axis. So the last thing I'll point out in this lesson is there are a lot of things we can customize with Matplotlib, a lot of them, more than even touched on in this lesson. So always just Google when you need to find something out about Matplotlib. There's lots of documentation. If you ever need to adjust some of the plot parameters, such as in this case, making the figure size bigger and the font size bigger, you may be working with something called the RC parameters. So once you set the RC parameters, that is going to be kind of a global change for all future Matplotlib plots for this session. So I'll run it. This makes it much bigger. So if I make any more plots after this, they're going to be just as big. So just keep in mind that it's not for a single plot. And then if I want to ever take it back, I should have saved the original default parameters in order to set them back. So here I have another plot that is the original size. So just something to keep in mind that you might run across the RC parameters that need to be set to get the plot looking just the way you want it to look.